Hello, Assalamualaikum everybody. You are welcome to the channel Chemistry, Physical and Inorganic Chemistry. So let's continue in our discussion about matter. Last time we has been discussed about gas and now we try to look closer to the other member of matter that's called solid and liquid. Liquid and solid, solid and liquid. Guys, I think it is interesting part to do little talk about general view of matter. Let's look around ourselves. Our finger touch your skin, feel your bones, skeleton. It made a matter that categorized as solid. And wait a minute. Yes, bloodstream in our body. It is a matter that categorized as a liquid. So you see, everything we are a matter and interact with the matter. So we move on to the list of contents. This is our discussion, the overall discussion of our lecture. First, we talk about general properties of liquid, type of intermolecular force to understand the nature of liquid. And then we move to the phase diagram, the melting process, evaporation, and vapor pressure. And part of it, you are you are learn in Form 5. General characteristic of solid, structure of solid, crystal structure, what is the lattice point and cell unit, amorphous, type of carbon, diamond, graphite, gold. It is part of a type of carbon. So yes, welcome to the intermolecular force. In this part, we learn how the intermolecular force can affect to the other molecule. Okay, we try to look the intramolecule. It is divided to two types, which is intramolecular force and intermolecular force. It is from the root intra, meaning to say intra means within the molecule. With force which keep molecule together, it is the real bond. But in intramolecular force, inter means between molecule, the attractive force within molecule. It is responsible for keeping matter in a solid or liquid phase. So that roots from the word inter, between the molecules. We have to look. We have already looked at intramolecular bond, ionic, polar, non-polar. It is learned previously. IM have to do with the attraction between molecule. So you see, we focus on the intermolecular force. So we consider intermolecular force attraction is not real bond. It is weak interaction between the molecule, but strong intramolecular attraction is made from bond. So intramolecular attraction exists between H and Cl within HCl molecule. This interaction controls the chemical properties, but the intermolecular attraction will control the physical properties of this substance. So when we zoom into the intermolecular force, actually there are many types of intermolecular force. But in your level, we are discussing of three types of intermolecular force. So Van der Waals is from the scientist that made Van der Waals. Intermolecular force for dipole occur between two polar molecules. When the two polar molecule which is in opposite dipole will attract to one another. So this one is a dipole-dipole interaction. It's so-called intermolecular, but it also known as a dipole-dipole interaction. But when it is occur to the two non-polar molecule, it results from a temporary uneven distribution. So it is occur, let's say, the hydrogen and hydrogen, the we atom hydrogen. When H positive meet to the H positive hydrogen atom, it's form a nonpolar molecule. And the nonpolar molecule form a interaction by dispersion force. So it is also have a intermolecular force, but it is very weak. So when we are looking to the hydrogen bonding, later on you can see another slide that discuss about the hydrogen bonding. It is occur between a hydrogen in positive end and a lone pair of electron and electronegative elements that roots from nitrogen, oxygen, fluorine, and sulfur. So it will form a hydrogen bonding. So it is extremely strong. It is slightly strong in compared to the other intermolecular force because the degree of the polarity is slightly higher. So this one is a three types that usually exist in the bonding in the liquid. Okay. So the strength of van der Waals force depends on three factors. Three factors that you have to look is size of the molecule. The more the size of molecule, it will increase the van der Waals force that form in the substance. And surface area of a molecule also contributing the strength of the van der Waals, and then the polarity of the molecule. Meaning to say the degree of polarity will decide the strength of the van der Waals force. Like hydrogen that I said earlier. And then all these example have in slide, the slide I provided it to you, the slide. But in this we are not discussing, we just discuss the key point and the general concept, the most important concept. Then later on when you read all the slides, you can understand easily. So let's see the IMF that arise from hydrogen bond. Hydrogen meaning to say when the polar molecule interactions between the hydrogen with the hydrogen. So two essential requirements for the formation of hydrogen bond is one molecule must contain at least one hydrogen atom attached at a highly electronegative atom, and the other molecule must contain FON atom that provide the lone pair of electron. It will contribute the degree of polarity. If the hydrogen atom, which is polarity is positive N, and FON is negative N atom. So look at the boiling point. So the most really exists, the intermolecular force will control the physical properties. The last previous slide state that the physical properties are controlled by IMF. Then we can know the strength of the intermolecular force by the axis of boiling point and melting point. Usually these two variables. So you see here boiling point between H2O water and HF is large gap. You see 100 degrees in compared to 19.5 degrees. How it is occur when we see the relative molecular mass is